All right. My last topic, disaster recovery. Important for every industry to consider, especially with hurricanes, especially with natural disasters, or for any type of situation. When I talk about business continuity, how to continue your business after an outage, we have three different types of categories. First of all is high availability. You don't want a single component to be your single point of failure. You don't want one thing breaking, shutting down your entire business. I was in Bogota, Colombia. I'm not making this up. I was in Bogota, Colombia many years ago, and the entire electricity for the entire country went out, all at the same time, 98% of the country. And what happened is that they had a power off button for the country that somebody leaned against. So their solution was to put a plastic box that you have to flip open to hit the button, because they turned off the whole electricity for the whole country. So no single point of failure. Secondly, continuous operations. Standard things like taking a backup or adding more disk capacity to a disk array that's already running your applications is routine activity, should not have to shut everything down. You should be able to do this while you are running your applications, continuous operations. But I'm going to focus on disaster recovery. What happens when a major outage happens that you have to recover from? And that's what the focus is for this topic. So disasters happen. The difference between a disaster and an annoyance is the duration of time. The lights go out and came back 2 seconds later, no big deal. The lights go out and they don't come back, well, we have to find another room, right? I mean, it's a duration of time that determines the disaster. It's usually something that people have a good sense of. Is an hour a disaster? Is 2 hours a disaster? Is 10 minutes a disaster? It all depends on the context of your business, your industry. So ideally, we want to be able to continue our operations in the event of a disaster with recovery that is predictable and reliable with reasonable costs. If it costs you $1 billion to restore your business, maybe you don't. Maybe you decide it's not worth spending $1 billion. All right? This is kind of like insurance policy. All right? And you want to, of course, protect your critical business assets, your data, during the process of recovery, especially if you recover at a different location that belongs to somebody else. So I have a very simple, straightforward, you start from the bottom and work your way up. First of all, you have to identify a new location you're going to recover your data from. All right? It could be a cloud, or it could be some other DR provider. There are companies that do this for a living. You recover your data, and you have to know, what did you lose? What did you have in the first place? It would be nice to know, if you know that you're losing 20 files, what can I do to recover those 20 files? You have to restart your applications. Now, if you are running at a new location that has different servers than the one you started with, this could be a problem. Maybe you don't have the right device drivers. Maybe you don't have the right operating system. So there are machine dependencies you have to be concerned about. And the last one, the human factors. I call these the 5 C's, command and control. How are you going to run your business at a new location? Are you going to have communications and collaborations between your employees? Are they going to stay in one city and work remotely? Are they going to move to the new place? Connectivity. Can they connect to the servers? Contingency planning. Right? Great contingency plan is, in the event of a disaster, we're going to do this until the recovery is finished. There's a grocery store that they lost all their computer scanners for the barcode, so they just said everything is $1. Everything in the grocery store is $1. You buy 5 things, you pay $5. And in the event of a disaster, we say, yeah, fine, $5, here you go. And what? It worked. It was a good contingency plan because it allowed people who didn't have scanners to find the prices just to say, I just count them. You have 19 things. Here's $19. Counseling. Disasters are terribly difficult to deal with. They have sent me to help clients in all kinds of situations. I had to help clients after 9/11, after earthquakes in Japan, after earthquakes in New Zealand, and the counseling is something that people didn't think about. How to deal with the fact that you're worried about your family, you're worried about your pets, you're not worried about your job. So, something to think about. So let's take a look at the timeline of a recovery. Here I have happy production in my data center, and I have an outage. First thing I got to do is somebody has to say, yes, it's an outage, I need to do disaster recovery. That's not something you decide lightly. Normally someone says, is it going to be more than 3 hours? If not, depends on the situation. You then recover the hardware in the operating system at the location you've designated, your disaster facility, and that's often referred to as your recovery time objective. You could say, I want this in 24 hours. In 24 hours, I will have recovered my operating systems, my applications, my data in 24 hours or 48 hours. You pick a time. However, you're not done yet because what happened when you had the outage? You had transactions that were partially completed. If I was moving money from my checking account to my savings account, it'd either be here or there, not in the middle. So we often refer to that as the RPO, Recovery Point Objective. If you back up every hour, possibly the data is 59 minutes old. If you back up once a day, your data could be 23 hours old. All right? So you have to then fix the broken pieces. All right? If there's money transfers or anything like that or partial, you have to either take them back out or finish them. You have to do something to make them whole. That can take some time. But once you do that, you're back in business. Now you're done. But that could take several more hours to repair any unfinished transactions. So for RPO, the technology drives the RPO. If I'm doing traditional backups to tape, my RPO might be 24 hours. If I'm doing point-in-time copies, snapshots, or flash copy, I can get this down to a few hours. Or if I'm doing asynchronous or synchronous replication, now I can have within seconds. The automation drives the RTO. How quickly can I recover? If I'm manually restoring from tapes and I have to pull them out of a cardboard box and look for them and put them out, that's going to be slow. If I have a tape library doing it, much faster. If I have it on disk, much faster. If I have scripts that do all the steps for me, much faster. These are the things people look at, having automation to make it possible. Now, these are terrible statistics. I got these from PricewaterhouseCoopers, and the numbers are still true today. 62% of companies do not have a DR plan. What happens when they have a disaster? They go bankrupt. What? They pray. Pray is not going to do anything. You think the stockholders say, well, at least they prayed? No. 62%. Hope is not a strategy. Right? 62%. Now, 19% have a DR in place. They have a plan. They have copies stored off-site at Iron Mountain or some other vault location. But they never test it and have no idea if it would ever work. Okay? 12% regularly test, and they still think they would have a failure in a real disaster. That they can test successfully because they know it's a test, but in the event of a real disaster, it wouldn't happen. Only 7% are confident that they can do their disaster recovery as scheduled. And I've met people in all of these categories, all of them. All right? Now, I used to have a chart that showed the 80 or 90 things that can cause a disaster, down to even one where a cat that was stuck in the rain jumped in through a window of the data center, landed on the main PDU, and caused a short circuit of everything in the data center. I mean, that's a terrible situation, but that actually happened. Why did they have the window open? Yes. Yeah, why was there a window? Yes, exactly. So I have determined that you shouldn't focus on the cause of the problem. You should focus on the impact, the effect. All right? So here are the four main effects. In the event of a disaster, you might lose your employees. For example, the bridge collapsed and they can't drive to the building unless they had a helicopter, which they don't have. Right? So you have work short, and this happens with bridges, with rivers, with situations where you can't drive to the office. Loss of technology. The electricity's down, the systems are down, the system stopped working, and you don't have access to your data, you don't have access to your applications. Loss of facilities. The systems are running, but there's a big smoke next door, and they told everybody to get out of the building, and you have to be out of the building. All right? So you lose the facilities. You don't have a place to sit in a chair and type. And then last one is failure in the supply chain. You're perfectly running fine, but you're getting parts and pieces from other companies, and they are not providing you parts and pieces. So you can't do anything because they have failed to deliver the parts and pieces you need. So these are the types of things that you can now focus on. There might be 20 different reasons why you've lost your technology, but it doesn't matter. You should focus on, given that it happened, here's what I do about it. And you can make plans for each of those effects. All right? And so we use a top-down approach. You look at the business process. Your business process is either 100% recovered or not recovered. All right? It does no good to be partially recovered on a business process. If you are a bank, your ATM machines either work or they don't work. Right? Now, if you're in a disaster situation, maybe your ATMs are your number one priority, and making loans is a low priority, because who makes loans in the middle of a disaster? But everybody needs the ATM machines. All right? So you need to prioritize, maybe gold, silver, bronze, which business processes you need in a disaster and which ones can wait till later. And you can pick. I can say, I need my gold ones up in 4 hours, silver in 48 hours, and maybe my bronze in 2 weeks or later. So you can make these priority decisions so that you can focus your efforts on the right thing. Every industry can divide their applications and their business processes for that. Now, if you have a business process, do you know all of the servers and databases that it involves to make it happen? Some people don't. So we have a product called the Tivoli Application Dependency Discovery Manager that will actually find it out for you. It'll say, hey, I have discovered that this information gets written here and is read by this application is written over here. And it'll tell you the servers and volumes you need that represent the business process. And lastly, can I run it in the cloud? Can I run this business process somewhere else? What are the dependencies to make that business process functional somewhere? And so now you have the beginnings of a plan. You've identified which business processes are gold, silver, or bronze. You've identified all the components, the servers, the databases related to that business process, and now you can identify what resources are needed to run that application. So back in 1983, before I started working in IBM, a group of clients came up with the list of 7 different tiers of disaster recovery. They call them business continuity tiers 1 through 7. And tier 1 was the cheapest storage, tape, all the way up to tier 7, which they thought was the impossible dream of everything switches over in less than half an hour. We have over 860 customers today worldwide switching in less than half an hour from one data center to another data center. So it's no longer an impossible dream. Now, you don't have to choose one for everything. You might choose 6 or 7 for your gold, 4 or 5 for your silver, and maybe 3 or 2 for your bronze. So you can pick and choose how you organize it. What's amazing about this is 30 years later, 40 years later, it's still valid. It still applies today. All right? So I'm going to go through and show you the different tiers and how they work. Tier 1 says, I'm going to put the data on tapes and store them in a vault, in a mountain somewhere, in a hole in the ground, at an office building somewhere. And in the event of a disaster, for my main production, I can then send someone to the vault, pick up the tapes, and take them somewhere. I was working with a client. They were doing this. I said, where are you going to take them to? We don't know. Who's going to decide? The guy who's taking the truck and picking up the tapes? You're going to just say, keep driving till you find someplace? All right, you need to make those decisions. Tier 2 says, you know what? I already know where I'm going to restore the data. Why don't I store the tapes there instead? So if you know you're going to restore it in Philadelphia, store the tapes in Philadelphia. If you already identified the location, it makes sense to have the tapes already where you need them. That way you don't have to move them twice. And the last one is, why don't I do it electronically? Why am I putting tapes in a cardboard box and storing it on a truck that's moving from place to place? I now have a lot of bandwidth, and I can send things either to the cloud or to another data center electronically. All right? And that enables all kinds of extra options and features. So that's tiers 1, 2, and 3, taking the backups, sending them somewhere. We have Spectra Protect. This is formerly known as Tivoli Storage Manager. A lot of people know Tivoli Storage Manager, but now it's called Spectra Protect. We can back up your laptops, your desktops, your application servers, even your virtual machines on VMware and Hyper-V. We can do compression and deduplication so that it can reduce the number of capacity petabytes you need to store the backups. We have a server that's based on DB2 database, very robust. One single Spectra Protect server can manage 4 petabytes of backup copies. You have many choices for storage pools. You can store it on tape, or disk, or object storage, or in the cloud. And for disaster recovery purposes, we have fully integrated support to have secondary copies of your data. So let's take a look at this. I can say that node A is part of my gold business process, and node B is part of my silver business process, and node C, it's my bronze. I don't even want to back it up because I don't need it. In the event of a disaster, I'm okay leaving it out. And so I will replicate the nodes remotely to a target server at a secondary location, and in the event of a disaster, I have now a plan to restore them from that tape. All right? We talked about Spectra Scale. You guys remember Spectra Scale? Well, Spectra Scale can back up to Spectra Protect. I have a lot of customers who are doing analytics, Hadoop, Big Insights, Hortonworks, and they say, how do I back it up? Well, put it on Spectra Scale. Now you can back it up. You can back up this critical data that you're running your analytics business on. Oops. If you're going to put things on tape, it'd be a good idea if it's encrypted. You know, we have horror stories of people who put things in the back of their truck and then they lost their truck, or they got stranded and a flat tire and they went to go get help and the tapes were missing when they came back. All right? So you don't want people to take your tapes. So you can do encryption at the application level. Spectra Protect can encrypt it if you want. You can encrypt at the operating system level, and the operating systems can tell how to encrypt or not encrypt. But most people encrypt at the library level. You tell the library to encrypt it, and we encrypt the tapes directly. Spectra Protect created a new category for storage. We used to support tape, either an automated tape library with physical tapes or virtual tape library, which was disk pretending to be tape. We also supported two types of disk. We could have disk used randomly, so each backup copy was a file, or I can treat disks like they were sequential, like a tape. So I can write block, 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 just like tape, and it was a lot faster. This had the advantage that I can add more disk volumes dynamically. This had the advantage that when I deleted a version, the space I could reuse right away. And since people like both of those features, they created now container pools that's better than both. The good part of this and the good part of this combined together as a container pool. And a container pool can either be on regular disk, SAN or NAS disk, or it can be in the cloud using cloud object storage. It could also be Amazon Web Services Cloud. It could be IBM Cloud. And we're going to support Microsoft Azure and Google later this year. All right? But it's a beautiful thing to have as an alternative to storing things on physical tape. So let's take a look at some examples here. In this example, down at the bottom, I want everything on premise. I don't want it to leave my building. I am going to back it up to the Spectra Protect server. My applications send the backups here, and the backups are stored in the cloud object storage. Or I can say, I'm going to back it up to the server, but the server is going to store it in the cloud. That has the advantage that it's already far away, business category 3. All right? Or I can say, I'm already writing it on premise to disk or tape, but I want another Spectra Protect server with a secondary copy of all my backups in the cloud. That way, if I lose my backup server here, I have another backup server ready to use. If the cloud is down, I have the on-premise one, and if the on-premise one is down, I have the cloud. And this last one is, what if I have a remote office, a branch office, some clinic somewhere that's small? I don't want to have a full Spectra Protect server. I'll just have the client code send it to a Spectra Protect server in the cloud, and now I can back it up directly in the cloud. Without Spectra Protect making these changes, you wouldn't be able to back up to the cloud because you don't have tape drives in the cloud. All right? So somebody asked me, how are we going to do things to the cloud? This is one of the ways. So using this approach with container pools, I can now transfer the containers to another location, object to object, and it could be on-premise object to a cloud object. Works great. And I can choose which nodes I send the data to. So I send the pools over, all the container pool data, and I make sure the metadata for the nodes are properly handled in the database. So we have the next tier is tier 4. And tier 4 is based on point-in-time copies, snapshots. We call them flash copy. What does EMC call them? Time finder. Different companies have different names for it. But what we can do is take a copy every 3 hours and send that copy to some other location. That way, we have a fixed point in time we can go back to that's relatively faster than restoring from tape from 24 hours ago. Tier 5 says, why don't I do one step better and just send the transactions to a second database and have those databases updated with the same transactions I have here, and now I have complete transactions at the secondary location with databases that don't have to be repaired for damage of some of the incomplete transfers. So let's take a look at some of the features for flash copy that we have on Spectrum Virtualize as an example. We also have this available for XIV, for DS8000, for flash systems. We can have up to 256 target copies. So you can do this every day for 256 days or every hour for 10 days. And you can have all of those copies available. Those copies can be delta changes only if you like, so they take up very little space. If you're going to back it up every 3 hours, you can say incremental flash copy that says keep track of the changes so that I only send the updates every 3 hours. So only the things you've changed in the last 3 hours will be sent, and that saves us a lot of time figuring out what changed. My favorite is this cascaded flash copy. Let's say I have a database that changes every 24 hours, constantly changing. I can take a flash copy at midnight, and then in the morning, everybody can use that as the source to make copies for their own purposes. Maybe this person wants to make a copy so they can generate reports, and this group wants to make it for testing and development. So now you can take copies of copies. With Spectrum Virtualize, we now offer a feature which allows you to flash copy directly to the cloud. So you can say, for this volume, send it to the cloud. And it sends the data to the cloud. You can have a full copy. You can have incremental copies. And now you have a remote copy of your data. Most flash copies, most snapshots are on-premise. So when you lose the building because an asteroid came from outer space, and now you just have a pile of bricks, you lose both the primary copy and the snapshot because they were in the same data center. Here, you actually now have flash copies in the cloud available. Available today, this is a feature, you can do that. And it could be Bluemix Cloud or Amazon S3 or any cloud that supports OpenStack Swift, which is an upcoming standard. We also have the ability to coordinate with databases and applications so that we have a clean flash copy. Now imagine if you do a flash copy while an application's running, whatever you got was whatever was on disk. And maybe some of the changes were still in memory, and some of the changes were not yet fully written to the database. So you get a partial result that the database recognizes and has to back out or complete or fix or do something like that. But what if instead we tell the application, suspend your updates, flush your buffers from memory, then we take the flash copy, and then we go tell the application, start over again. All right, this is one of my 19 patents, so I'm very proud of this one. And let's say we keep several versions. I'll keep 3 versions. So maybe a version at 8 o'clock in the morning, and one at noon, and one at 5 o'clock in the afternoon. And I rotate around that. So I have 3 versions of my data at any time. And they're complete copies that don't have to be repaired because I suspended it, got a clean copy of the disk, and resumed the application. Minimal impact to your application. This works across the board. Both IBM and non-IBM devices are supported. If we want, we can also spin off those copies to Spectrum Protect if you want to store them in the cloud or store them somewhere else on disk or tape. Spectrum Protect can store them as well. Now in Tier 5, when we said we can make sure that a database is completely accurate at the secondary location, people say, what about the unstructured data that's outside the database? Well, here's where we can use the cloud object storage to provide that support. So my databases, I send over the transactions, and for my unstructured data, I store in 3 locations. The primary data center, a cloud location, and maybe my third is a disaster recovery facility. 3 copies of the data. All right, but it's not 3 copies, it's 1.7 copies that I spread across those locations. So in the event I have a disaster, I don't have to restore the unstructured data. It's already available as is. So people are now recognizing that this is a great way to take care of the unstructured data, and now they only have to focus on the databases themselves. Much faster restore time to make the databases ready to go. Tier 5. All right, Tier 6 is that I'm going to mirror the data to the remote location. So when I make an update at the primary location, I send that update to the secondary location. And I pick all the volumes and all the databases, all the unstructured data gets sent over to the second location. But that's just the data. Tier 7 says, don't just copy the data. Also coordinate switching over the network and starting up all the applications. Make it a full environment recovery. And Tier 7 was what, back in 1983, people thought was the impossible dream. We have this running hundreds of clients. So we have to explain the difference between Metro Mirror and Global Mirror. Metro Mirror is synchronous, and synchronous means we write to the primary system, we send the data to the secondary location, we wait for the secondary location to send us the data back saying, we got it, it's safe, and once we got confirmation, we then tell the application it's in both locations. So this is an RPO of 0, because there is no way you can lose data between the two locations. Both locations are identical. RPO equals 0. 0 data loss. Now, unfortunately, the time to wait for this round trip is 1 millisecond for every 100 kilometers. Every time you write to primary location and it has to go 100 kilometers a round trip separation, that's an extra millisecond. So if it took 5 milliseconds and you're going 300 kilometers, now it's 8 milliseconds separation. So that's going to slow down your business slightly. For some businesses, that's too much. I've seen people go 6,000 kilometers and have 60 millisecond writes. That's their choice. So if you don't want to wait for that, and I tell you, this is the speed of light through fiber optic cable. We've been to every Star Trek convention. We haven't been able to go faster than the speed of light. Star Trek can, we can't. So we have Global Mirror. And Global Mirror says, I will write to the primary and tell the application I'm good. And then a few seconds later, I'll collect all the updates and send them to the secondary location. So the secondary location might be 3 seconds behind, 10 seconds behind, 2 minutes behind, depending on how much they collect and send over. And that's good enough. Maybe not having it exactly RPO 0 is okay for some applications. You'll clean it up with transactions and logs. So the advantage here is that I don't slow down the primary business. I continue to run at full speed, and the copies will eventually catch up. So we support 2-site, 3-site, and 4-site locations. 2-site, I have my primary location at a disaster facility. With a 3-site, I might have a bunker location that's nearby for synchronous Metro Mirror, and then a global mirror far away. So that has the advantage that I have both a RPO 0 copy and maybe something that's 2 minutes behind far away, depending on the event of the disaster. Now, some people don't like the cascaded copy because if they lose the bunker, they also lose the third location. So they prefer multi-target where the bunker is written independently of the remote location. So we support that also now. It's called MultiTarget Mirror. And then we have people who now want to have 4 copies of the data. So 2 in one location and 2 in another location, just for added protection. Amazing. I couldn't believe anybody would want 4 sites, but yes, there are banks, there are insurance companies, they want that added protection. Now, an interesting thing happened when we discovered looking at actual disasters. In the event of an actual disaster, does everything fail at the same time? No. Sometimes in an earthquake, one disk fails, and the other one is, then it fails, and the next one, then it fails. It happens as a rolling disaster. And as a result, some things might be successfully sent over to the secondary location and others not sent. That could be a real problem. Let's say that I am moving $100 from my savings account to my checking account. And first, I log the update that says, I'm going to make this transfer of $100. And then B says, I'm going to subtract $100 from savings, and I send that over. And then the C volume adds $100 to checking. and then I update the log to say I successfully moved the data from savings to checking. So if I do all 4 of those updates, money is transferred correctly. All right? What happens if one of those didn't work? All right? Let's say I do 1, I do 2, 3, failed, and then I do 4. And 4 got over correctly saying, the money transferred. Hey, what happened to my $100? Well, it says it's successfully transferred, so it must be in your checking account. Too bad. All right? You can't have that happen. You have to do consistency across volumes. So we call this a consistency group. All of the volumes that represent your application need to be correct at the remote location. To help with that, we have the Copy Services Manager. This is a product used to be called the Tivoli Storage Productivity Center for Replication, but the name was too long. So we shortened it to Copy Services Manager. 3 words and not 5. And what it allows us to do on the DS8000, it also works with SVC, also works with XIV, is with one command, do all the steps necessary to make something happen. We can suspend, we can freeze, we can resume, we can start, we can pair up all the volumes together, we can coordinate all the activities, we can even create practice volumes so you can do a disaster recovery test of your data without affecting your backups. All of these things with one step, one command. So it really made it easy for you to manage your environment. So we support XIV, Spectrum Accelerate, and the Flash systems. We support Spectrum Virtualized Storewise and the V9000, and we support the DS8000. So whatever you have, we can manage it with Copy Services Manager. If you have a DS8000, we now can put the Copy Services Manager right there on the HMC. You don't even need a separate server. We also have a nice feature called HyperSwamp. We have HyperSwamp for DS8000. We have HyperSwamp for SVC Storewise, and soon we'll have HyperSwamp for the XIV and the Flash system A9000. Here's how it works on Spectrum Virtualized. We have 2 nodes. Remember the I/O group and the 2 node pairs? We write it here. We send it over to the second site. And if you write it in the second site, it gets copied to the first site. So it's bidirectional. Now I can run applications in either location, and I have 2 copies of the data. All right? The GUI is aware of what site everything is in. The reads always done locally, so they're short distance reads and not long distance reads. Why go to the long distance when we can get it locally? And instead of having to have a quorum disk as a physical drive in a closet, in a building, in another location that you had to run fiber channel cables to, and nobody liked that, now it's a Java program you can run on any server connected over the network. IP-based quorum. So this is nice because now you can have an IP-based quorum in the cloud or on your intranet internally, and in the event that Site 1 is no longer talking to Site 2, maybe you have accidentally broken the cable, they're fixing the road, and the backhoe pulled up the cable by accident, and they no longer talk to each other. You don't want them to be updating your activities at the same time. So they both go in read-only mode. They talk to the IP quorum. IP quorum says, you are read-write, you are offline, and everything's back in business. Okay? So that really has helped a lot of people implement this, because having a third building to be the tiebreaker has been difficult for people to implement physically. IP-based quorum solves this. All right? So in summary, you have to look at and train all your people to know, in the event of a disaster, what contingency plans are they going to do? How are they going to continue running their business? Where do they go? What do they do? The more automation, the less they have to do it manually. Your process should be well defined. It should meet with security and compliance so that you are not exposed in your business and that nobody has access to data they shouldn't have to. And then finally, the technology. Make sure that you have the technology to restore and it is consistent and compatible with what you have the primary location so that you don't have a lot of inconsistencies with your drivers or your devices or your host bus adapters. Any questions? Okay, does this help? Is this something that I'm looking at the people who have 62% no DR plan? Okay, I know some of you are there. People think, I can't do this. I show people. I've had to go to a customer in Kansas. They had a tornado hit the wrong building. They didn't hit the IT department building. They hit the spare parts building. So there's spare parts everywhere. The tornado hit the building, and nothing but spare parts all over the place. And they said, wow, if that was the IT department building, we'd be out of business because we have no DR plan. Now's a good time to do a DR plan. So they sent me in, and I had one day, and in 6 hours, we had beginning to end everything they needed for our DR plan on whiteboards. We took pictures of whiteboards, boom, done, finished. It really isn't that hard. They go, we spent 2 years thinking about making a DR plan, and you did it in 6 hours. Well, that's just what it takes. There's no excuse. If you want your business to survive a disaster and continue to be in business, you need a DR plan. It's important. Thank you very much.